All right, circle conjecture 4 says, if an inscribed angle of a circle intercepts a semicircle, so what we're going to draw is we're going to put, here's a dot. We're going to make a semicircle, so we need to have a center, and we need to have 2 points that are endpoints of a diameter. Endpoints of a diameter. Because they have to intercept a semicircle, and what is a semicircle? Anybody know what a semicircle is? Half of a circle. A semicircle is half of a circle. Okay, so you have to make 2 dots that make half of a circle, so they're endpoints of a diameter. So I'm going to go through the center, so there's my diameter of a circle. Now this next dot, you can draw approximately where I draw it, but it doesn't matter because it's going to make the same angle I make no matter where you put it. So I'm going to put mine over here, but you can put yours anywhere and it should make the same angle mine does. Okay? You can put your dot here, you can put it 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 here. You can put it anywhere. And no matter where you put it, it's going to do what mine does, which is it's going to make a right angle. So no matter where you put it, it's going to make a right angle. And the reason for that is because what we just did is we drew an inscribed angle whose intercepted arc is half of a circle. So if the arc is half of a circle, then the angle has to be a 90-degree angle no matter where you drew the angle. Okay? So this is a 90-degree angle by default because the arc is a semicircle. So if an inscribed angle of a circle intercepts a semicircle, 180 degrees, so it's half of a circle, then it forms a right angle. So circle conjecture 1 was talking about a central angle. Circle conjecture 2 was talking about an inscribed angle. Circle conjecture 3 is an extension of circle conjecture 2. Circle conjecture 4 is an extension of circle conjecture 2. So really, even though we're on the 4th one, we've really only learned about 2 things. We've learned about central angles, which are not very interesting, that the angle in the middle of the circle is the same as the arc on the outside the circle. And then we learned about these things called inscribed angles, which are kind of interesting. They're saying if you have an angle that's made on the edge of the circle, that it is double the length of the arc, the measurement, the angle measurement of the arc. And now we're learning some interesting things about that, okay? All right, go ahead and we're going to move on to the next page, which has examples 10 and 11. Now, at home, I was referring to different colors, markers, colored pencils, whatever. If you don't have colors here, come up and grab some if you want them. I'm going to keep using colors throughout the notes today. All right, so for this one, they have an angle right there that they've labeled as 5x. So it will not be uncommon for me to say, okay, if you have an angle that you're working with on a worksheet, go ahead and start by taking marker and writing on that angle. And then with your marker, follow that angle out towards the edge of the circle. And what will happen is once you follow the marker out, you'll be able to see what the arc is that we're referring to. So this angle matches that arc. So if this arc is half of the circle, then what is the measure of that arc? It's half a circle. How much is the arc if the arc is half a circle? 180 degrees. So if the arc is 180 degrees, then what's the angle? If the arc is 180, what's the angle? 90, because the arc, in this case, anytime we have an angle where the vertex of the angle is on the edge of the circle, that means it's an inscribed angle, so it's half. That's what we just did. And so now the equation that we're solving is we're going to say 5x equals 90. And then to solve the equation, we can just divide by 5. And so what does x equal? X equals 18. 90 divided by 5? All right, now sometimes we have a problem like example 11. And in example 11, instead of them showing you the measure of an angle, they showed you the measure of an arc. So the measure of x has to do with the measure of the arc. So what I would do here is I'm going to take my color and I'm going to trace the arc. And I can see that the arc touches this edge and this edge right here. So I'm going to take those two edges and I'm going to trace them down so I can see what angle we're talking about. So I can see that those two ends traced back and they correspond to this angle right here. Does that make sense? So arc X corresponds with this angle. Now, I don't yet have enough information to find that angle. That doesn't really help me. Court, did you have a question? You what? You can do. Yeah. So we can use the 52-degree angle if you want to do that. Okay, so since we had the X and we know it corresponds to this little angle right here, we can't really do anything with it. So what Keld was suggesting is that we use the 52. So what we can do right here, we can start with the 52. Close, yeah. Start with the 52, and I'm going to trace this out. And I'm going to see what arc this one goes with. So I can see that it goes with this whole part right here. The 52-degree angle, then I know that I'm going to take that 52 degrees and I'm going to multiply 52 times 2. And what is 52 times 2? 104. So I know that this arc right here is. So if that arc is 104, can I figure out the other little arc? Yeah, how do I do that? 180 minus 104. So because I can see that those two arcs together are half of a circle. So 180 minus 104 is 76. And then it turns out I didn't even have to find the little. I didn't even have to use this other side of the circle. Technically, this angle right here is a 90-degree angle, but I didn't even need to use that to do the problem. I could have used it to do the problem, but you guys Keld helped us use a different route altogether, so we ended up not needing it. So X is 76 degrees. How do your brains feel? Terrible? Terrible. All right. Circle conjecture number 5. If a quadrilateral is inscribed in a circle. All right, somebody tell me, what's a quadrilateral? four-sided shape. So what we're going to do is we are going to draw a four-sided shape inside the circle. For it to be inscribed in the circle, all four of the vertices, all four of the corners, have to be touching the edge of the circle. That's how it works for it to be inscribed, okay? You can draw a perfect square, you can draw a trapezoid, you can draw any shape you want, it does not matter, okay? You can make it look some sort of congruent, you can make it look lopsided, you can do whatever you want, okay? So you can draw this like me, or you can draw it different than me. It does not matter. So I'm drawing my first side like this, and then I want mine to look kind of wonky, so I'm going to draw it like this, okay? So this is how I'm doing mine. Yours does not have to match mine for ours to make the point that this one is trying to make. Okay. So that's what my four-sided shape looks like. Again, yours does not have to match mine to make this work. Okay, we good? Okay, so here's what I'm going to do. And this is what you're going to do as well. We're going to pick two colors, and we're going to pick two angles that are across from each other in our four-sided shape. Okay, so I'm going to do this angle right here, and I'm going to do this angle right here. It doesn't matter which two angles you pick, just pick two angles. Okay? All right. So I'm going to start with one angle, and I'm going to take my marker, and I'm going to start by just showing this is the vertex of that angle. And so I'm going to start by tracing that angle, and I'm going to follow it out to see where the arc is for that angle and how much of the circle it is, okay? So there's the angle. I'm going to follow it out. And here's part of the arc, and it goes all the way around. So for me, that angle goes with an arc that is the majority of the circle. That's it for me. It's a major arc. Okay? And now I'm going to take my other color, and I'm going to trace the vertex for the other angle, and I'm going to follow it back the other direction. Okay. So when I traced that, how much of the circle did I trace? I traced all of the circle. So how much of the circle is all of the circle? 360 degrees. Okay, so if I traced all of the circle, if I traced 360 degrees worth of the arc, then how much angle do I have for the angles? 180. Does that make sense? If I traced 360 degrees worth of the arc, then that means that the angles are 180. Okay, so what I'm going to do in here is I'm going to draw arrows on either side, and I'm going to say these two angles together are 180 degrees. Does that make sense? Because their two arcs combined make the whole circle. Their two arcs combined make the whole circle, which is 360 degrees, which means that their two angles combined have to make 180 degrees. Does that make sense? So their two arcs combined make the whole circle, that's 360. That means the two angles combined are 180 degrees. That means that the two angles that are opposite of each other are considered to be supplementary. They are supplementary. Okay, so let's finish this sentence. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. they add to 1. So circle conjecture number 5 is yet another extension of circle conjecture number 2. So basically we have learned 2 things. We have learned that the central angle is the same as the arc. The angle that is in the center of the circle is the same as the arc of the outside of the circle. We've learned that. The second thing we've learned is that if you have an angle that is made on the edge of the circle, then the arc is double the measurement angle. And if we've learned that there are some special things that happen when this is the case, and that's what 3, 4, and 5 are all about, is there's some extra special things, okay? But memorizing circle conjecture 1 and 2 are the most important things. 3, 4, and 5 are just the extra bonuses of like, oh, those are some cool things that can happen. Okay, does that make sense? You can flub your way through 5. But 1 and 2 you gotta have memorized. You gotta understand those. Okay? So what we're going to do now is we're going to practice a little bit before I overwhelm you, because after this, circle conjecture 6 moves on completely to something different. Okay, it moves on to another idea altogether. So let's go ahead and do example 12, and then I will get you guys started on the practice worksheet so you can start practicing these ideas. So it says measure of angle HIF. So if you guys remember from Math 2, HIF is this angle right here. HIF is that one, that's 92. IFG, this one right here is 84. So they want the measure of GHI, so they want this measure right here. How could we find that measure right there? We can do opposite angles, so these 2 angles. So what would the measure of GHI be? How'd you get 76? 180 minus 84, so it's not 76, it's 96, okay. Supplementary, They're supposed to add to 180, okay. And then the other one is FGH, so this is the other one. And so how are we going to find that one? Okay, so what is this one going to be? 88. Okay. All right, so with these other ones, circle conjecture 3, 4, 5, you can always kind of fake it till you make it by just taking a marker out and drawing the vertex of the angle and drawing the arcs, and you would be able to solve the problem. You would just take a little bit longer to do it because you'd be using the idea of the angle and the arc have that relationship of a 2-to-1 ratio, okay? That you take the angle and you double it to make the arc, or you take the arc and you half it to make the angle. So you could still solve the problems if you forgot those conjectures. They would just take a little bit longer to do. Okay? All right, let's go ahead and get started on the practice assignment. If an angle is formed by a tangent and a chord, so we're going to draw the same picture twice so that I can show you the 2 different variations of what it can look like. So here, I'm just going to draw 2 tangent lines kind of the same way. Here's my 2 tangent lines, so I'm just drawing them the same way. See my 2 tangent lines? And then here's my point of tangency. So remember, a tangent line is a line outside of the circle that only touches it in one spot. And then I'm drawing, at the point of tangency, I'm drawing a chord. A chord is a line that is inside the circle, okay? So I have a tangent line and a chord. It needs to touch the point of tangency, because what we're doing is we're making an angle. So on one example, we're going to make the angle right here. On the other example, we're going to make the angle right here because I want you guys to see two examples, one where the angle is little and one where the angle is big, so you can see the difference, okay? So two examples, little angle, big angle, okay? These they're going to feel like inscribed angles because it's going to work the same, where this angle, the vertex of the angle is kind of on the edge of the circle. And again, the measure of the angle is going to be half the measure of the arc, but these are not considered to be inscribed angles because the entire angle is not inside the circle. You can see that part of the angle is outside the circle, but in my head, even though it's not called an inscribed angle, I still think of it as an inscribed angle because it still kind of works the same. Okay? So if you want to say the fake inscribed angle or the faux inscribed angle, like F-A-U-X, the faux inscribed angle, the fake inscribed angle, I will let you guys do that because that's essentially what it is. Okay? So here the relationship is 1/2 x is the angle, and x is the arc, or 1/2 x is this angle, and x is this arc. And so I'm going to show you guys, so the angle is what I marked there. Here is the arc. This is kind of the weird one. There's the arc inside here. So it's kind of strange. I don't know if you could see that. And then here's the angle here, and then there's the arc. So these ones are kind of weird looking. But the relationship is the same as an inscribed angle, even though it's technically not called that. So 1/2 x is the angle, and then x is the measure of the arc. So we still have that same relationship. And these do not technically have a special name. They're just an angle that's made between a tangent line and a chord. So if an angle is formed by a tangent and a chord, the measure of the angle is half the measure of the intercepted arc. So it still feels like circle conjecture too, even though it's different. These circle conjectures that I'm calling these are not like universally known. These are like Miss Rice math notes so that you have something to refer back to. If I'm like, oh, that's circle conjecture 5, that is like specific to Miss Rice class. This is not like, oh, if you go to another student at Riverside High School, they'll be like, oh yeah, circle conjecture 5. I'm familiar with that one. Oh yes. They probably know them as other ways. This is just something that makes it easy for us to refer to them. Okay? All right. Make sense? All right. Next page. Okay. So we've got a couple of these situations happening here. Circle conjecture 6 is mostly happening right here with angle x. You can see it right there with angle x. Okay? But we also have a lot of circle conjecture 2 happening. We got inscribed angles happening a lot. Those seem to be very common this unit. They happen all the stinking time. All right, so they want us to find the values of x and y. What you'll notice this unit is that one person might have one approach to the problem, another person might have another approach to the problem. We can all arrive at the same answer using different methods, and we're all good to do that. So it's typically when I go through these notes, one class might do it one way, another class might do it another way, and we're all fine, okay? So does anybody see any method for how we could get to solving for x, solving for y? Yes?
Solving for y, as you can see, at angle, I think, right in.
Okay, can you tell me how you know? Aside from the fact that it looks like it might be one. You can tell, and it has to do with inscribed angles. Well, actually, we can't tell because, oh no, we can tell. Yes, Ella, I saw your hand first. Yeah, QL goes through the center, it's the diameter. And so I'm going to go ahead and draw on this so that those of you who need to see it can see it. This right here is a 90-degree angle, and the way that we can tell is if we start here and we go to the edge. When I landed on Q and landed on L, I landed on endpoints of the diameter. And so this is that semicircle right there. I believe, is that circle conjecture 4? I believe. So this is 180 degrees. That makes this 90 degrees. Okay, so we have enough information to solve for y. How do we do that? (90) and 35, so this would be, what would y be? 55? So we can do 180 minus 90 minus 35 is 55. That's how we can solve for y. Okay. Anybody have any ideas for x? X is saying the angle right here. So the angle, it's angle LJK. The angle right there. Yeah, Corey. Do you have ideas?
I thought I did, but I don't think so.
You don't think so? Okay.
I was going to say, I think that's, this y, incongruent with y is the open circle above 35 and 98. So, there, I think.
This part?
Yeah, isn't it where we do like the x and the middle part, right?
This part and this part?
Number something. I don't know why is this one. Number 2, I think. Listening to Braille
Yeah, that I did feel like that's what I was listening to. James, did you have an idea? You were raising your hand. You don't have an idea. Ella, what is your idea? X is in reference to the angle that is made from LJK. So this angle right here. But the arc right here would be helpful if we could find the arc. Sam, what do you have? Okay, so if we did 35 times 2, that would tell us this arc, which is 70. Okay, yeah. So, does everyone's comfortable with if that's 35, then this arc is 70? Are we all comfortable with that? Okay. Now what we're going to do is we're going to use our new circle conjecture to solve for x. Okay? So the new circle conjecture, I'm going to do this. I'm going to see if I can make it so that it's visible without getting too convoluted in here. I have yellow. I'm going to try yellow and green and see what happens. Okay, so what we have here is the angle x. Can you guys see this yellow? Oh, the screen is yellow. Why would you be able to see yellow? I'm going to do orange. Okay, the angle right here. Can you guys see this? This is angle x right here. Everyone see angle x? That's angle x right there. Does everyone see that? Okay. Now, per the most recent conjecture, we saw the angle x corresponds to this arc. You guys see that arc? So if the arc is 70, what's the angle? 35. So we just solved that x is a 35-degree angle. And that's from the most recent conjecture. So we're going to say x is 35, y is 55. So believe it or not, x and angle q are the same angle measurement because they share the same arc. They share the same arc, so they're the same angle measurement. Yeah.
So how do we know that diameter?
because it crosses through, you can see right here. Those of us with color copies can see it better, but the center is right here. Yeah, so typically they'll tell you if something, like, oh, if it looks like assume it's a diameter if it appears to be a diameter. And normally I would play devil's advocate and say we couldn't assume that was a diameter, but I saw that there was a center dot and that we could see it went through that point, which is why I let us make that assumption. Yeah. All right, circle conjecture number 7. All right, so this one, we have a line that is tangent to a circle, so we're going to draw a tangent line again. Go ahead and draw your tangent line. All right. You don't like the word tangent? But you guys go off on tangents all the time.
I don't mind the word, it's just you're saying it so much.
Tangent? Oh. 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 All right, so draw a center point in a circle, tangent, and then draw a line to the tangent line, and it should touch the tangent line at the point of tangency. And then draw a right angle at the point of tangency, because there's a right angle right there. It's a 90-degree angle at the point of tangency. You guys shouldn't have told me that, because now I feel powerful. Tangent? Oh. So if a line is tangent to the circle, then the line... Oh, I should write this where you can see it. Did everyone see the picture of the tangent line? Okay. Then the line is perpendicular to the radius drawn to the point of tangency. And one of their favorite things to do with this is not just make a right angle there, but to make right triangles. They love to make right triangles. And what is our favorite formula with right triangles? Starts with a P or the alphabet, depending on if you use the name of it or the variables. Pythagorean Theorem. So a lot of times they'll take this and they'll like erase half of it. And then they'll be like, oh my gosh, guys, it's a right triangle. If I erase half of it and then draw another side, it's a right triangle. They do that all the time with these. And they're like, I don't know. And then they're like, how cool. A squared plus b squared equals c squared. And we're like, yeah, I get it. I've been through math before. I don't know. They just do that all the time. Yeah, right. Well, okay. So that's what they've done in the next few examples is they have like thrown in some Pythagorean theorem so that you can have some flashbacks to math problems before. So if we look at example 14, the tangent line that's in 14 is PR. They just erased half of it. P is the point of tangency. OP is the radius that was drawn to the point of tangency. Tangent? Okay. And then this is your 90-degree angle right there. No, that was the radius. They made a 90-degree at the tangent line. Yeah. At the point of tangency. P for point of tangency. 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 Tangent. 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 1, 2, 3. Tangent. Okay. All right. They want the measure of the third side. Does anyone recognize this Pythagorean triple? What's the third side? Is it 13? Okay, but we can go ahead and solve for it, just in case we need to. So we got 5 squared plus 12 squared equals OR squared. So in case you need remembering, the right angle always points to the hypotenuse. That's the C side. The C side is not in a gang, in case you were confused by what Court said. Okay, so we've got 25 plus 144 equals OR squared. I'm just doing the Pythagorean Theorem. 25 and 144, anyone? 169. I'm sending this to her mom afterwards.
She would not expect any of us.
What's the square root? What's the square root of 169? Oh, Jack, you were right.
Wow, he's so smart. Smart.
Jack tried to save us from having to do the problem, but we didn't let him. All right. How many tangent lines do we have in example 15? 2. We have 2 tangent lines, 2 points of tangency, 2 90-degree angles being formed at those points of tangency. Point of tangency L, point of tangency N. How many degrees are in a 4-sided shape? 360. So how are we going to solve for x? Right up here. 117. And then once we get that sum, what are we going to do? Okay, so 297 is what that sum is, and we're going to take 360 minus that sum. I don't know why I didn't just believe you, because I can do that math in my head, but there it is. 63. Yes? Opposite angles only equal 180 if they are inscribed in a circle. Yeah. In this case, they happen to equal 180, but that is a coincidence, not a general rule. Yeah. All right, last one. We have another tangent line. What line is the tangent line? Okay. So you have the Pythagorean Theorem you can do to find the third side. Here, let's move this out of your way.
What's the Pythagorean Theorem again?
Oh, well look, we wrote it on our note.
Right, but I
Thursday, so we'll strength this.
Wait, where did my notes go?
I don't know. Leave them at your table?
A squared.
Oh yeah, let's go, bro.
So that's 20, right? Would it be 7 squared plus 19 squared plus equals 20 squared?
It would be what?
Squared equals that squared. How do I know which one's A, B, or C? Does it matter?
So where's your right angle?
Right here. Or right here.
The right angle always points to the C. And the A and B don't matter, they're interchangeable.
49 squared. I guess it's 49. And 19 times 19. 361. Equals 400. So you get 410 equals 400.
Why did you?
Equals 400? Or 410?
Well, because those added together, so it's A squared plus B squared equals C squared. A squared equals C squared.
7 squared plus 19 squared, 410.
410.
Then you square root.
What is that?
Square root. C squared.
Oh, so I don't. Okay, so the square root of 410.
It's going to be a decimal.
Should I do this near 100?
I did 3 decimal places.
3.248. That's it?
Uh-huh.
That was my plan.
So it would be 24 squared plus 10 squared equals C squared.
That's fine.
Did you get 26 for 16? Yes, 16.
I got 26 for the whole side, but X is only this part. See that?
Yeah.
So if this is the radius and this is 10, and the whole thing is 26.
Divided by 2?
Yeah, and it's not degree, because it's a length.
So then I would have to divide that by 2?
Not divide by 2. If the whole thing is 26, this is a radius, this is 10, then what's left over? 16. Because it's not half.
Minus 16. So now I subtract 16?
No, it's just 16.
Oh,
You say 10 plus x equals 26.
mhm.
10 plus x equals 26. Minus 10. X equals 16.
I guess it's
You don't like my 6?
the measures of the arc or angle. Is this what we've been doing? Or we have to do notes again?
We have to do notes again. But if you look at your assignment, Kel, at the very end there's a section 1 through 9. You could work on that. All right, guys. We got some notes to finish. How are you feeling? Very bad? Are you sure? Are you really feeling very bad? You sound pretty chipper. Can somebody less confusing answer me, please? How are we feeling? Horrible? Why do you guys sound so chipper? We are horrible! Yeah, it's very confusing when you guys do that. I don't even know. Okay. We have these notes. Ready? Are we ready? We are almost done. If it helps, we will have a cheat sheet this unit, and these is today and tomorrow. These are one of the days that I get nervous about because these are the long days. So apologies in advance. They're not all like this, these 2 days. I hate pressuring you guys. Yeah. I hate when I know that I'm going to overwhelm you. All right. Are we ready? Kel, just in time. All right. Circle conjecture number 8. Here's the picture. If an angle is formed by 2 secants, or 2 tangents, but we have 2 secant lines right here because they go through 2 points in the circle instead of just through 1, and they intersect outside the circle, then the measure of the angle, so here is the angle that we're measuring, it's right here, okay, that's the angle, so I'm going to write x right here. I'm going to take a marker. We have 2 arcs, we have a little arc, and we have a big arc, so I'm gonna label these big, little. Okay? So here is the formula. You guys ready for the formula? Okay. We have our picture labeled. X, big arc, little arc. Okay, so the formula is x for the angle equals the measure of the big arc minus the measure of the little arc. Oh my gosh, I was going to spell little wrong. Minus the measure of the little arc divided by 2. Where did that formula come from? I don't know. I'm good at algebra, not geometry. Don't ask me these things. Huh.
The E guy with the E symbol. You know that.
That was a tidbit. Sometimes I know tidbits. Yes. 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 I just said that. Yeah. And nice thing is I have a recording from last year where I helped students write a cheat sheet from start to end. I'm not going to do that with you guys, but I will post the recording. It will be posted. I literally helped them make a cheat sheet from beginning to end. Like, here, we're writing our cheat sheet together, and it's recorded. I will post it. Okay? All right. So here are the examples. Big arc minus little arc divided by 2. That's all we got to do. So what is x? It's 35. 90 minus 20 divided by 2. That's all we got to do. So we do big arc minus little arc divided by 2, and that equals x. Big arc minus little arc divided by 2. Okay? So we can type that in. We can make it look exactly the same as what it looks like on the paper right now. 35. Okay. So here is one where they drew 2 secant lines to make the angle. Number 18 is a version where they drew 2 tangent lines to make the angle. And this is one that is kind of interesting because when they draw 2 tangent lines, they can get away with only labeling one of the arcs because the 2 arcs make up a full circle, which means you can do math to find the other arc. So if this whole arc, now this arc, it starts, here's the point of tangency, here's the point of tangency. So the arc that they labeled actually goes, here's the big arc. The big arc is from here to here. So the little arc is actually the rest of the circle. So how big is the little arc? 120. So the little arc is just whatever completes the circle. They do that a lot when they do this type of problem with tangent lines, where they won't give you both angles for the arcs, and you feel like there's not enough information for the problem, but there is. Okay, so now we're just going to do big arc minus little arc divided by 2. Big arc minus little arc divided by 2. And then what do we get? 60. Big arc minus little arc divided by 2 is 60. Ooh, they got complicated. So here they did a secant line and a tangent line, and they gave us one arc that we needed and one arc that we didn't need. And then they did not give us an arc that we needed. So 65 is needed. 120 is not. But we do need this one. I don't know. So how are we going to find the missing arc that we do need? So 360 minus 120 minus 65. So the missing arc is 175. Okay. So now we have the arc that we need. And now we can do big arc minus little arc divided by 2. So big arc minus little arc divided by 2. Oh, you can use it, but it's not used for big arc minus little arc. So it's used in the problem, but it's not used for big arc minus little arc. No, sorry, that was my bad. Not completely unnecessary, just unnecessary for the formula. Yeah. Yep. All right. Big arc minus little arc. Okay. The next one, circle conjecture 9, has a picture like this. Okay. So this angle and this angle are actually the same. Anyone remember what those angles are called? This is from Math 2. Starts with a V. The vertical angles. These are vertical angles. So anytime you have angles that are formed in an X like that, they're always the same on each side. And the formula here that we're going to work with, we're going to talk about this arc right here and this arc right here. So these are arcs that are made from 2 chords in a circle, or they could be 2 secants in a circle. We're going to call this arc 1 and this arc 2. And the formula is x equals, oops, can't see it, x equals the measure of arc 1 plus the measure of arc 2 divided by 2. So very similar to the last one, you're just adding them. Ms. Rice, where does that formula come from? I don't know. Okay, I don't know. Somewhere mathematical. Somewhere geometric and mathematical. I will look into it never, okay? I don't know. History will tell you that it's from white dudes, but that's a lie. It came from ethnic dudes before the white dudes, and then the white dudes stole their history. There we go. It makes a lot of sense if you look up the history. All right. So, we got it? Oh, there you go. Alex, I was trying to read your mind and I was doing a bad job. All right. Are we ready for some sample problems? Okay. Super easy. All right, so we are adding arc 1 plus arc 2 divided by 2. Oh, 93. You were right, Kel. Beautiful. I was not at all surprised. Okay, now this one is different. Do you guys notice how this one is different? So we're going to say 160 plus x divided by 2 equals 120. You guys see that? Okay, so how do we go about solving for an x that is in the middle of the problem? Yeah, we're going to have to do some stuff backwards. I do not like the fraction, and this is going to happen on your worksheet, so keep this in mind. Yeah, I'm going to multiply the 2 to the other side right away so I don't have a fraction in the problem. So I'm going to take the 2, multiply it to the 120. So it just cancels on the left side. The left side stays nice. And then now I've got 160 plus x equals 240. I'm going to solve for x by subtracting the 160 over. What does x equal? 80. Is that what you said? I thought you said me? Sometimes when notes are long, I lose my mind as I do them. So, all right, you guys notice what's wonky about example 22? The labeled angle's in the wrong spot. It's wonky. I'm using an outdated term. That was slang when I was a kid, too many years ago. James. We can't work with the 139 because it's not the right angle. We got to work with this angle or this angle instead. How could we find them? So we can't double 139 because it's not an inscribed angle. Remember, inscribed angles have to be on the edge of the circle, and this is not on the edge. It's also not in the middle. So this is not anything that we've learned. So, but how could we use the 139 to find these ones? Yes. Subtract 139 from 180 because they're on a straight line. And so if they're on a straight line, that means that they must make 180 degrees. So this is 41. This is 41. Okay. Yeah. Oh, you were thinking that this was 360. Yeah. I got you. Okay. I thought you meant outside.
No, that's faster, but...
Yeah. All right, so now what do we do? Add what? So we do... Tell me what to add.
41. 39, right? 41, 41. 41 equals.
41 equals.
Equals.
Okay. And then what do we do?
Multiply by 2. The things cancel out, multiply by 2. Then you get 82 equals 40 plus x. Solve for x. You get 42. 42.
All right. I will work on getting the rest of the answer key done and scanned so that you have it to reference for today. All right?